Welcome back, my math magicians. We are going to take a look at section 8.2, a single population mean using the student t-distribution. So this is going to be a little bit new. The good news is it works almost exactly like the first section. So in the previous section, we used the normal distribution, but we rarely know the population standard deviation. When we don't know that, and the sample standard deviation is given, we use the student t-distribution. And inside the student t-distribution, we have something called the degrees of freedom. That's going to be n minus 1. It's a lot. You'll figure it out. Things fall into place pretty easily. So here in the qualifications, or I guess the characteristics, or how to choose between using the student t-distribution and the normal z-distribution. If you do not know the population standard distribution, but you know S, so the sample standard deviation, then you use the student t-distribution. If you know sigma, it's normally distributed, or the sample size is greater than 30, then you use the normal z-distribution. Here's a picture of what it looks like, and we'll talk about some of its properties. So properties for the student t-distribution. The first one is that the student t is similar to the normal z-curve. If you look at the picture, you can still see they start low, they go up high, and go back low again. The second thing is that student t distribution has more area in the tails. Than the normal z. So we have more area in this region, down in here, than the normal z-curve would. And last, as your sample size increases, and by increases we mean really huge, the student t starts to approximate the normal z. So it approximates or approaches So from there, we're going to look at constructing a confidence interval using the student t-distribution. Again, this is where sigma is completely unknown. Same steps as we used before. So we're going to list what we know. We're going to take what we know and use StatCrunch to find anything we might be able to glean from the information we already know. We're going to find our critical values. Before they were z's. Now we're looking at t's. We're going to calculate our EBM, and then we're going to find the upper bound and the lower bound, just like last time. One thing that is going to be useful is to go back and refresh on degrees of freedom. We call it DF. And that's n minus 1, so our sample size minus 1. So here we go. Suppose you do a study of acupuncture to determine how effective it is in relieving pain. You measure sensory rates for 15 subjects. Well, right there, I have alarm bells going off in my head, telling me that we already know our sample size. With the results given, use the sample data to construct a 95% confidence interval. So that means we want our confidence level to be 0.95. For the mean sensory rate for the population, we're assuming it's normal, from which you took the data. So we have n, we have a sample size. We have the confidence level, 0.95. And then the only other thing we have is this big old string of data. Well, long, long ago, in a galaxy far away, we calculated things. We calculated all kinds of summary statistics for lists of data like this. So I'm going to put in my list of data. Feel free to fast forward through the entering of the data. Eight point one. Where did it go? There it is. 5.5 and 6.9. That was not a 9. There we go. So this is a little bit of a blast from your past. And it appears that StatCrunch may have given up the ghost. There we go. Where'd my data go? There it is. So I am going to go to Stat, and I want to calculate, and I want to calculate the summary statistics in columns. I used the first column. I have to find my compute button. So now, StatCrunch has provided me with a sample mean of 8.2. I'm going to take that out another decimal place or two. 2267 7. And I have a sample standard deviation of 1.6722. We need, or I guess we don't know, sigma. That is our clue to use the student t distribution. So this part was step 1 on the list. Step 2 on the list is to find the critical value. So to find the critical value, I'm going to go to stat. I'm going to go to calculators. But this time I'm going to go all the way down to t. I'm going to choose between. Now here's where degrees of freedom comes in. We have an n value of 15. Degrees of freedom is n minus 1. So 15 minus 1 would be 14 for degrees of freedom. I want a 95% confidence level. So I know that critical value is 2.1448. The third step is going to be to calculate the EBM. The EBM, or our margin of error, has its own happy little formula. We had a formula with the last section that used the z-score. Well, now we're going to replace the z with the t. Instead of sigma, we're going to use the sample standard deviation and our n. I'm going to plug in what I know. My S value was 1.672. Is that right? Nope, 2 2s. And my sample size was 15. When I plug that in the calculator, and this should actually be the square root of 15, the square root of n. When I plug that in the calculator, I end up with 0.926. So here's what that means. When I go set up my confidence intervals, and I want my upper bound and my lower bound. My lower bound is still x bar minus the EBM. So I'm going to do x bar minus the EBM. And then I'm going to do it again for the upper bound. But I'm going to use plus the EBM. So we can be 95% confident that the true population mean, and we are guessing that our population mean is going to be approximately 8.227, is between our lower bound, that's 7.301, and our upper bound, 9.153. The last one uses StatCrunch again. We've got a random sample of statistics students who were asked to estimate the total number of hours they spend watching television in an average week. The responses are recorded in the table. Use the sample data to construct a 98% confidence interval for the mean number of hours statistics students will spend watching television in 1 week. Here's the thing. I am going to spare you watching me plug this data in. It works just like the last one I did, where I went and got the summary statistics, just like we did at the very beginning of statistics. Here are your StatCrunch steps, or you can come over here and use these. I worked it both ways. Both were pretty simple. We know that we are going to be 98% confident. That's why we're putting a 0.98 in our level in StatCrunch. We get a true population mean of 6.13, repeating. And it is between 2.40 for the lower bound and 9.87 for the upper bound. And all of that can be calculated using StatCrunch. If you want help plugging these into StatCrunch or you have any questions, please don't hesitate to swing by. We can sit and work on them together if we need to. You can email me questions if you have them. Otherwise, I will see you in class.